All right, we're getting there, we're getting there. Secants, tangents, and angle measures. More angle measures. So we already had central angles, and we had inscribed angles. We got two more. One is interior to the circle, that's not the center. The other is exterior to the circle, so we'll be seeing those. And we're also talking about secants. I mentioned a secant line to you before, as opposed to a tangent line. Remember the tangent line? You know, just touches the circle in one place, but a secant goes through and includes a chord of the circle, so it says it intersects the circle in exactly 2 points. That's a secant line. So we're talking about those today and talking about these angles and how these things relate. So let's think about two lines, two secants that intersect at the center of the circle, and that's special. It creates four central angles, and we would know that if this was 120, then this would be 120 because those are vertical angles, so they're congruent. And that if the central angle is 120, then the measure of the arc is 120, and the measure of this arc is 120. So these two arcs would be congruent, both be 120. And that's stuff that we saw before, okay? That's stuff we saw before. And that's when you have central angles, okay? Because it's a one-to-one relationship between the measure of the angle and the measure of the arc, central angles. What happens, though, if you're not at a center? You have two chords, two secants, right? Secants with chords that intersect the circle, but they obviously do not intersect at the center, okay? Now, I have noted for you that the measure of this arc is 200, not the green intersection, but the red dot intersections. So from here to here is 200. That's why it's a little more than the 180, which is what the green intersection arc would have been. So that's 200. Now, I think it's pretty obvious to us that that's not 200, that's not 200, and that's 200, and it doesn't work that way. So there's things here that we are going to have to try to figure out. Now, we can't just know this based on this, but I'm just saying we know there's some different relationship here. It can't be this relationship here of the same. It just doesn't work here, would not work here. But that was true because it was a central angle. This is not a central angle. It's interior to the circle, but it's not at the center, okay? Not at the center. And what we're going to see, let me, for the sake of this discussion, pretend that the measure of this arc right here is 40. Just pretend it's 40. If this is 40, and this is how easy this is. Now, we don't know that it is. I'm just purporting that. But this is how easy it is. If that's 40, that arc is 200. That's what this angle intersects or intercepts. And this is 40. If that's true, then this is 120. And how did I get that? Average. Think average. 240 divided by 2, 120. So if this had been 20, then those would have been 110, okay? So in this particular picture, this is not at the center. These are two chords, part of two secants, two chords that intersect not at the center. But one of the things that we know is that the measure of that angle is going to be the average of these two arcs. So you average those two arcs. And I believe it's 82. I believe it's 82. So this would be 82. And this would also be 82 because those are vertical angles. They are congruent. 82. Think average. So find x. Here's x. And they've given us that this arc is 62 and this arc is 96. So if we're thinking average here, which, you know, this is not at the center, if we're thinking average here, you add the 96 and the 62 and divide by 2. So that's 158, I believe, divided by 2, which is 76. So that's 76 and that's 76. It's just not the answer to the question. Watch it, be careful. That's 76 and that's 76. This is not 76 because that's not those, that's this. But I do know that that's got to be 180 because that's a line. So if that's 76, this is 104. 101, whichever one. I guess I got that wrong. I divided by 2. It should have been 79. And so that would make that 101. Yay! Another mistake. Yay. All right, find x. So in this case, they flipped the switch on us here. They've given us the x is the arc, the interior angle is the 60, and the other arc is 25. In other words, this and this have to average to be 60. So somehow these two arcs got to add up to 120. See if that makes sense, because you're going to add these two and divide by 2 and get 60. So they got to add up to 120. So if that one's 25, then this one is 95. Think about it. 95 and 25 make 120. 120 divided by 2 is 60. 95. By the way, they made that a formula, and you can do that. You can do that. So they asked us to find the measure of angle x. They've given us these two arc measures here. And so we average those like we did earlier. We average those, we get 82. So this is 82, but that's not the question. They asked us for this angle here. But we know these two are supplementary. So if that's 82, they have to add up to 180. This must be 98. More of the same. And then this one has the missing arc. So we got to think about what number goes here. So the average of the two arcs is 67. Well, if the average of the two arcs is 67, then somewhere I've got to have 134 out of the two arcs. So if that's 30, then that's 104. Think about it. Add the 2, you get the 134. You divide by 2, you get the 67. So D. A little working backwards, a little insight into what's going on here. That's how that's going to work. So if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Because these are basically inscribed angles. So you've got a secant and a tangent meeting at the tangent point. And so the measure of that angle is going to be 1/2 the arc. Because it's an inscribed angle. Same thing here. It's an inscribed angle. So this will be 1/2 the intercepted arc. So that's using old stuff in this particular case. So they asked us to find the measure of angle QPS, which is this angle here. Well, its intercepted arc is 250. Since that's an inscribed angle, remember inscribed means the vertex is on the circle. Since that's an inscribed angle, it's 1/2 and double, so that's 125. Let me point out to you a couple of things while I'm sitting here. Because if that's 250, then this is 130. This has nothing to do with this particular problem, but hey, right? Because this is all of this, and the whole thing has to be 360. See, so they got to add it. That'd be 110. They got to add up to 360. Yeah. So if that's 110. Then this will be 1/2 that, which is 55, which works out real good because this is a line, so those have to be added to 180. See, it all fits together. It's beautiful. It's math. Find the measure of arc BCD. Now, BCD has to be this arc, right? They force us to go through the C to get to the D, the way that's written. So they want to know the measure of this arc. Well, if that's 108, then this is 216 because that's like an inscribed angle. Right? So it's 1/2 and double. And if that's 216, the whole thing's got to be 360. So this is 360 minus the 216. And you do the math right there, and you get 144, I believe. Yep. 144. And now we're just kind of, repeating the same concepts, and it's just different numbers and practice and all that kind of stuff until we get to this. And this is interesting. This is what happens when you have an exterior angle. Okay, in all these cases, whether you're dealing with two secants, a secant and a tangent, or two tangents, all of these have an exterior angle. So we've done 4 things here. We did central angle, inscribed angle, interior angle, but not at the center, and now exterior angle. So there's 4 of them that we're gonna look at here. And they all have the relationship. Central angles are 1 to 1, whatever the central angle is, the intercepted arc is. Inscribed angles, it's half and double. Interior, remember it was average. Remember that? We just did it a few minutes ago, average. And now we got this one. And this one is half the difference. Now, the interior was half the sum. That's what average is, half the sum. So the exterior is half the difference. So it's similar, but it's different because one's interior, one's exterior. And we just got to know that. And so it's half the difference of the 2 arcs. And of course, you look at this picture, it's the big arc minus the little arc. Don't, that should be the big arc, right? Minus the little arc. The big arc minus the little arc. Otherwise, you get a negative number if you did the little one, subtract the big one. That would make no sense. So it says find the measure of arc BC. It's unfortunate they started off on the tough end of this one here. They want us to find the measure of this arc here. It started on the tough end because it would have been easier to have given the 2 arcs and find the angle, and you would have learned the concept. But here's the deal. The measure